So after I get done with it, I'll upload it and it'll be available. Now, if you have any questions as we're going through this, just unmute yourself and then ask your questions. I like questions. My biggest thing when I'm using Zoom is I forget to unmute myself when I start asking the question, start talking. So if you don't get a response back from me, it could be that you forgot to unmute yourself. And we'll do this every Monday. And this is our direct instruction for February 22nd. Now we're going to cover various topics. Part of this I'll be working problems on my tablet, and part of it I'll be typing up into a Word document. In this Word document I will send out to everybody. So you don't need to write that down. And then, like I said, the video will be out there too. Now this covers chapters 1 and 2. And starts out with integer operations, and I know some of you may be comfortable with integer operations already. Now when we're talking about integer operations, you might have a problem looks like this. We got a -2 plus a -3, and want to combine those together. Well, we got some shortcuts that we're going to apply at any point in time. And our first shortcut is if you got a negative, then a parentheses, then another negative, and then some kind of number. A negative becomes a positive 5. If you have a negative, and then you have a positive number inside, this becomes a negative. And if you have a positive and then you have a negative number inside, this becomes a negative. And then if you have a positive and you have another positive, that becomes a positive. Now it's fairly easy to remember, if the signs are the same, it always becomes positive. If the signs are different, it becomes negative. And we're going to see this pattern continuing on in some of the different problems we'll look at. Now, I don't like to think of these as adding or subtracting numbers. I like to think of them as combining numbers. And we have two cases. Case 1 is where the signs are the same. And the first thing we do is we ignore the signs. Then you add the numbers. And the sign of the answer is the original sign. Now we'll also have case 2 where your signs are different. One's positive, one's negative. We're going to ignore the signs. We'll subtract the smaller number from the larger number. And the sign of the answer is the original sign of the larger number. And let me put those on a separate page so we can see them all together. Okay, so this is going to be our combining numbers. I like a step-by-step approach. I'm looking into how to put some other YouTube videos I have that focus on a step-by-step approach where you can have access to them. For this example here, first off, it's got a shortcut we can apply. The -2 carries down, and we have a plus parentheses minus. Well, that becomes a minus. Remember, when the signs are different, then it becomes a minus. Now at this point, the signs are the same. We got -2 and -3, and again, I'm not thinking about adding or subtracting. So step 1 says we ignore the signs. So I'm going to be looking at 2 and 3. We're going to add the numbers. 2 plus 3 gives us 5. And it says sign of the answer is the original sign. Well, they originally both were negative, so this will be a -5. And that's our answer. Now another example, let's say we got negative 7 and we have minus negative 2. Now no matter where you are in algebra, you always want to apply those shortcuts. So here we got a negative, parentheses negative, so that's going to become a positive. And now we're combining these numbers together, and we got case 2. Signs are different. So in case 2, we're going to ignore the signs, just like before. So I got 7 and 2. We're going to subtract a smaller number from a larger number. 7 minus 2 gives us 5. And the sign of the answer is the original sign of the larger number. Our larger number is 7, which originally was negative. So that's going to give us negative 5 for our answer. Now this applies not just when working with integers. The reason why they have this in the review chapter is you'll have this same principle apply when you're working with x's. So for example, if I had negative 7x minus a negative 2x. We're going to talk about what these are a little later on tonight. But again, we have our shortcut. Really, the shortcut just says if you have a single item here. It doesn't have to be a number. Here we have a single term. Well, negative parentheses negative becomes positive. And we're going to see later on that these are something called like terms. And to combine like terms, you add or subtract the numbers that are out in front, which is a negative 7 plus 2. So it's going to give us the same negative 5, but we'll have an x on there. So the same principle holds true throughout this entire course. Now that's combining numbers. You can think of it, combining numbers again as add or subtract. Now there's more for integer operations than just combining numbers, adding and subtracting. We also got multiplication and division. So for our multiplication and division, you multiply or divide just like normal, but for multiplication, if you got a negative times a negative, that's going to give you a positive. If you have a negative times a positive, that's going to give you a negative. If you have a positive times a negative, that will give you a negative. And if you have a positive times a positive, that'll give you a positive. And you probably notice a pattern here. Signs are the same, it becomes positive. Signs are different, it's negative. Now for division, we'll divide just like normal, but we just have to look what the signs come out as. If you got a negative divided by a negative, that's going to give you a positive. If you have a negative divided by a positive, that's going to give you a negative. If you have a positive divided by a negative, that'll give you a negative. And if you got a positive divided by a positive, that will give you a positive. And again, you probably notice the pattern. If the signs are the same, it becomes positive. Signs are different, becomes negative. Let me clear that off, and then I'll put a couple more examples down. If we have, for example, negative 2 times negative 3. Well, signs are the same. Negative times a negative is a positive. So 2 times 3 would give us 6, and we drop the positive, so our answer would be 6. Now, oftentimes a fraction symbol represents division. So if I had this right here, this says negative 6 divided by 2. Well, that's really a positive 2, so negative divided by positive gives us a negative. Signs are different, it's negative. And then 6 divided by 2 gives us 3. So our answer would be negative 3. And again, if you have any questions as we're going through this, just be sure to ask. Now the second topic we're going to take a look at is exponents. And let me clear that off. If we have 3 to the 4th power, when you got an exponent up here, this is referred to as your exponent. It's also referred to as your power. So that's read as 3 to the 4th power. Now what that 4 means is we're going to take 3 times itself 4 times. Well, 3 times 3 is 9. I'll bring the other 3's down. 9 times 3 is 27. And 27 times 3 is 81. Now, if you have a TA3, TA4 calculator, I noticed the book, the e-book mentions it in a few places. To do an exponent, if I want to do 3 to the 4th power, you press your 3, and then you press your caret, and you see the buttons light up when I push them. That's the caret, and then 4, and then press enter. And that gives you your 81. Now on your calculator, some of them you may be able to plug in, and some of them you have to understand what does the exponent affect. And we got a note for that. Note, the exponent only affects what is to its immediate left unless there is parentheses. Then it affects everything inside the parentheses. So the exponent only affects what is to its immediate left unless there's parentheses, and affects everything inside the parentheses. What I mean by that, let me clear that, or I'll just do an example here. If I had negative 4 squared, for example, this exponent here is only going to affect what's to its immediate left, so it's only going to affect the 4. So the negative will carry down, and then 4 squared I can rewrite as 4 times 4. And that negative is carries down, and 4 times 4 gives us 16. Now compare that to this. If you have negative 4 inside a parentheses squared, the exponent only affects what's to its immediate left unless there's parentheses. This time there's parentheses, so it's going to affect everything inside the parentheses. So this will be negative 4 times negative 4. And remember, a negative times a negative gives you a positive, and then 4 times 4 gives you 16. Some people, when they plug that in the calculator, they think that plugging in this first example should give them a positive 16. Well, it's implied you had to put parentheses around there if you wanted to affect everything inside. Now, there's one other thing I want to mention about exponents, and I'll put the note down here about it. Anything to the 0 power is equal to 1. There's a couple oddball cases to that, but pretty much for this class you can consider that to be true. What I mean by that is if you have 5 to the 0 power, for example, that would equal 1. Anything to the 0 power is equal to 1. Now the reason why, if I look at 2 to the 3rd, that's 2 times 2 times 2, which is 8. 2 squared, 2 times 2 is 4. 2 to the 1st is 2. 2 to the 4th is 16. Going up, I got 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 would be 32 for the next one. Going backwards, 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So by definition of how exponents work, anything to the 0 power is always equal to 1 for that reason. Now, we have something called an order of operations. And it helps us to figure out how to simplify problems. Specifically, it works real well when everything's a number, numeric in some sense. Order of operations
Mr.
is,
Hayes?
yes.
Oh, sorry. Before we moved on, I just wanted a real quick question on the negatives. So when we did the -4 squared, so it's -4 times 4, and we got the -16.
Right.
So what if it was cubed? Is it still -4 times 4 times 4, or is it -4 times 4 times -4? Like when you do it in sequence.
If you do not have the parentheses, then it only affects what's to its immediate left, so the negative would carry down, and then you'd have 3 4s, and that would give you a -64. On the other hand, and this time it is going to give us the same answer, but for different reasons. If you got it inside of parentheses, what's to its immediate left is a parentheses, so you rewrite this as -4 times -4 times -4. Then -4 times -4 gives us a +16, and that carries down. And then a positive times a negative is negative, and 16 times 4 gives us 64. So it's only really when it's an even where you see different answers for those.
Okay, thank you.
Mm-hmm. Now, they got I'm trying to think what the name of it's called. It's a clever little rhyme that helps you remember what to do. Please excuse my dear Aunt Sally. Now, the first letter of each tells us what to do. Let me finish formatting this. Okay, the please. The please stands for parentheses. It's actually a little bit more than that. It stands for brackets also. And a slightly different version of that also means you do an absolute value. Now, typically what this means is you do whatever is inside the parentheses or brackets or absolute value. In the case of absolute value, it actually means get rid of the absolute value. Now, a lot of people interpret this as get rid of the parentheses, and that's not what it means. It says do whatever is inside the parentheses. Now the E, that's exponents, so you do exponents next. My dear, the M and D is multiply or divide as you encounter either one from left to right, and the AS, Aunt Sally, that's add or subtract as you encounter either one from left to right. Now we'll see that throughout the course the order of operations creeps in, but again, especially beneficial if you got numeric examples. And let me make up one. Sometimes I'm not very good at making those up. I was going to steal one out of the book, but let's take a look at this. Okay, please do what's inside the parentheses. Well, we got the parentheses, so we'll do what's inside the parentheses. Within the parentheses, you still follow your order of operations. I don't have any parentheses in here. Excuse exponents. Well, I do have an exponent that's 2 squared. Well, that's kind of a boring one. I'll go steal one out of the book. 2 squared is 2 times 2, which is 4. Now I'm still doing what's inside the parentheses, and there's only one thing left. Add, subtract. So we got 4 minus 4, which gives us 0. So now we're done with what's inside the parentheses. And again, that please part does not necessarily mean that you're going to get rid of the parentheses. You're just going to do whatever's inside the parentheses. So now we go down to the exponents. And we have one exponent here. Everything else carries down. Now 0 to the third power is 0. 0 times 0 times 0. And I've kept the parentheses here because a number right next to parentheses indicates multiplication. So please excuse my dear. Multiplication and division. Well, there's a multiplication. So 1 times 0 is 0. And then Aunt Sally. Addition, subtraction. 3 minus 0 gives us 3. And that would be our answer. And let me go grab one. And order of operations, section 1.2. We haven't talked about fractions yet, so let me look at 102. This is on page 29. Then 102, then we got negative 3 times negative 2 squared times negative 5. Please do what's inside the parentheses. Well, if you look at this, there's nothing to do inside the parentheses. There's just a negative 2 here and a negative 5 here. So then, excuse exponents. Well, I do have an exponent, this one right here. And remember, exponent only affects what's to its immediate left. So negative 3 carries down. And negative 2 squared, if you want to do it over on the side, then that'd be fine. Negative 2 squared is negative 2 times negative 2. Remember, a negative times a negative is a positive. So we're going to replace that with a positive 4. And then the negative 5 carries down. Notice I've kept the parentheses there to indicate multiplication, because the negative 3 next to the parentheses indicates multiplication, and these two next to each other indicates multiplication. Please excuse my dear. Multiplication, division. So I do these two here. Negative 3 times 4 is negative 12, and then I'll carry down the negative 5. I'm still doing the my dear multiplication division part. Here I got negative 12 times negative 5. Negative times a negative is positive, and 12 times 5 gives us 60. And that would be our answer. So again, the order of operations again guides you on what to do. Now you're getting an abbreviated lecture on these topics. So if there's any topics that you just need some more examples on, some more video explanation on, I got videos on about every math topic there is already recorded. So you just need to let me know, say, hey, I'd like to see some more questions on the order of operations. I'll send you a video that you can watch that goes into more depth. Now this next topic is fractions. And fractions was one of them that they had down. So I looked at what should you be able to cover, and down here is fractions. And so let's take a look at that. First thing we need to talk about is what prime numbers are. Now, just our definition of a prime number, the only factors are 1 and itself for a prime number. For example, if I had 3, the only way I can write that as a product is 1 times 3. So 3 is prime. On the other hand, if I had 4, I could rewrite it as 1 times 4, or I could rewrite it as 2 times 2. So we have different factors besides 1 in itself. So 4 is not prime. Now the prime numbers are 2, 3, 5, 7, 11. What you're going to find, the prime numbers, there's actually an infinite number of them, but almost 95, 98% of the problems in mathematics revolve around those first 5. Sometimes it gets up to 13, but that's majority of what the problems are based upon. Now, to find a prime factorization, I'm going to show you by example. Now, prime factorization means, like, if I have 8, I'm going to rewrite that as 2 times 2 times 2. Everything's a product, and they're all primes. They're all the numbers in our list we have here. Well, if you can see them, fantastic. If you can't see it, then you can do a tree breakdown. I start with 8, and I draw a tree. And I start with my first prime. I start with 2. And I ask myself if it's divisible by 2, and it is. 2 times 4. Now 2's prime, so I circle it. And then I go to 4, and I'm still on my first prime, and I'm asking if it's divisible by 2. And it is. 2 times 2. Now 2's prime, so I circle it, and this 2's prime, so I circle it. And I can't go any further since I'm at the end of the tree breakdown. So all the numbers that are circled then are my prime factorization. Now let's look at a little bit more interesting problem than that. 120, for example. I start with my first prime, which is 2. And it is divisible by 2. And if you're not very good at seeing if it's divisible by this number or that number, use your calculator. Take 120, divide by 2, and see what it gives you. If it gives you decimals, it doesn't go into it evenly. This is 2 times 60. 2's prime, so I circle it. Now I'm still on my first prime, which is 2, and this is divisible by 2. 2 times 30. 2's prime, so I circle it. Then 30, it's divisible by 2. 2 times 15. 2's prime, so I circle it. Now for the 15, I ask myself if it's divisible by 2, and it isn't. So I then go to my next prime, which is 3. And it is divisible by 3. 3 times 5. So 3's prime, so I circle it, and 5's prime, so I circle it. So my prime factorization would be 3 2's, and then a 3, and then a 5. If you want to write this in exponents, you could write 2 to the third times 3 times 5. But this is basically our prime factorization. Now that's going to help us to simplify fractions. So for simplifying fractions, our first step is to write the prime factorization of the number on top, numerator, and the number on the bottom, denominator. And step 2 is cancel whatever is the same. Now in this case it'll be a number, but it doesn't have to be. It could be an x, it could be x plus 3. They both could have an x plus 3. So that's why it's written kind of vague, whatever is the same, because it's not limited to numbers. It will be in the first chapter. Now what I mean by those steps, let's take a look at an example. And after I do this one, I'm going to talk about a shorter way you can use to simplify these. It all depends on how good you are with your basic number skills. Okay, want to simplify this. That'll be our instructions. We want to simplify that. Now, step 1 says write prime factorization, number on top and number on the bottom. So I'll do my tree breakdown here. 16 is 2 times 8. 2's prime, so I circle it. 8 is 2 times 4. 2's prime, so I circle it. And 4 is 2 times 2. Both of those are prime, so I circle them. So we got 4 2's. Now 20 is divisible by 2. 2 times 10. 2's prime, so I circle it. 10 is divisible by 2. 2 times 5. 2's prime, so I circle it. But also 5's prime, so I circle it. So this will be 2 times 2 times 5. That's step 1. Write the prime factorization at the top and at the bottom. Now step 2. Cancel whatever's the same. The only guideline is one's on top, one's on the bottom. So I'll cancel this 2 with this 2. I'll cancel this 2 with this 2. Now you might look at these 2's and think, well, they're the same, but they're both on top. So we're left with 2 times 2, which is 4, and then a 5 down below. So our answer would be 4/5. Now if you're pretty good at looking at them, another technique is you think the largest number, they divide into the top and bottom. Well, and you don't even have to think of the largest number. If you can just get started, then it gets you closer to the answer. If we recognize that they're both divisible by 4, then we can divide the top part by 4 and the bottom part by 4. 16 divided by 4 is 4, and 20 divided by 4 is 5. Remember I said if you can just see anything that are both divisible by, you can get started. Like 16 and 20, if I saw they were both divisible by 2. And I'll always show a lot more steps than I'm sure you need to in your work. I try to show the steps so you not to skip any, so if you need to see them, they're there. 16 divided by 2 is 8. 20 divided by 2 is 10. And then I notice, well, they're still divisible by 2. So I can take 8 divided by 2 and 10 divided by 2. So 8 divided by 2 is 4, and 10 divided by 2 is 5. So again, if you just see some number that divides into both of them, you can get started, and then after you do that, it'll be simpler, and you probably then can see the next step. Now there's a third way, and that's on the calculator. And if you're not at this place where you can add numbers, subtract numbers, to exit out of anything on a TA3, TA4, now this is not the same for other calculators, so if you got a TI-30, it won't work. You press the second button and then the mode button. That'll exit you out of anything. So if I press second here and then mode, you see above mode it says quit. That'll exit you out of whatever you're in. Now to simplify, 16 over 20. If I do 16 divided by 20 and press enter, it gives us a decimal, and to go from decimal to fraction form on your calculator, you press your math button and then enter. And then I'll give us our 4/5. So to go from decimal to fraction on the TI-83, 84, you simply press Math, Enter, Enter. Now that's simplifying fractions. Let's take a look at multiplying fractions. So I'm going to clear that off. Let's say I got 16 over 9 times 12 over, let's say, 20. And we want to multiply those together. So multiplying fractions, your first step is to write the prime factorization of all the numbers. Step 2, cancel if possible. Only guideline is that they are the same, and one is on top, one is on the bottom. And then step 3, multiply the tops, numerators, and multiply the bottoms, the denominators. So if we come over here, step 1, I won't show the tree breakdown again, but write the prime factorization of all the numbers. 16 is 4 2's. 9 is 3 times 3. 12 is 2 times 2 times 3. And 20 is 2 times 2 times 5. Now step 2. Cancel if possible. Only guideline is that they are the same, and one is on top, one is on the bottom. So this 2 here will cancel with this 2. This 2 here will cancel with this 2. This 3 here will cancel with this 3. And I don't see anything left to cancel there. So I'm left with 2 times 2 over 3 times 2 times 2 over 5. Now, if everything disappeared, you'd always be left with an invisible 1, which you can put there then. Now, step 3. I say multiply the tops, multiply the bottoms. Well, 2 times 2 is 4, times another 2 is 8, times another 2 is 16, and 3 times 5 is 15. Now, another way you could do that is if you're pretty good at seeing the numbers, you look at a number on top and a number on the bottom that both can be divided by the same number. For example, here's 16 and here's 20. Those are both divisible by 4. 16 divided by 4 is 4. 20 divided by 4 is 5. So I got 4 over 9 times 12 over 5. Now here's a 12 and here's a 9. They're both divisible by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So we got 4 over 3 times 4 over 5. Now there's nothing else I can simplify, so I multiply the top parts, the numerators. 4 times 4 is 16. And the bottom parts, 3 times 5 is 15. And that'd be our answer. Again, this method works out pretty well if you can look at the numbers and see what they're both divisible by. Now, the calculator can also do this for us. So if I plug it in as I see it, I got 16 divided by 9 times 12 divided by 20. And then do enter. And then we get a decimal, and we know change from decimal to fraction. We do math, enter. And that gives us 16 over 15. Now for our division. If we had, for example, 4/5 divided by 8/10. No, that's a bad one. That'll give us 1. Let's do something else. 16 over 25. 16 over 10. Yeah, that should work better. Okay, so we're dividing. To divide fractions, what you do is you rewrite as multiplication by changing the symbol and flipping the fraction following the division symbol. Now, when I say flipping the fraction, that's called a reciprocal. And then step 2 is you multiply like normal. Okay, so rewrite as multiplication by changing the symbol and flipping the fraction. So this becomes 4/5 times, so that division becomes times, and then we flip this fraction. Top goes to the bottom, bottom goes to the top. That's what a reciprocal is. Reciprocal means fraction flipped. You swap the numerator and denominator. And then you multiply like normal. Well, remember in multiplying, we see if we can divide a number on top and a number on the bottom by the same number. These are both divisible by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. So I got 1/5 times 10/4. And here we got a 5 and a 10. Again, only guideline is one's on top, one's on the bottom. You can divide them both by the same number. These are both divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. And we have one more. 2 and 4 are both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. 1 times 1 is 1, and 1 times 2 is 2. So our answer would be 1/2. Now division, you have to be careful plugging in your calculator. To plug this in your calculator, you have to make sure you put parentheses around each fraction. That's how you'd have to put it into your calculator. So I'd have my beginning parentheses, then 4/5, so 4 divided by 5, closing parentheses, and then divide by, and then beginning parentheses around the second fraction, which is 16 over 10. And then press enter. Now we get a 0.5, so you do a math, enter at that point, and that would give us our 1/2. Now any of the other operations you don't have to do that on, but division, again, you have to put those parentheses around the fractions. Now, oops, let's go here. Let's take a look at finding the LCM of numbers. Now the LCM stands for least common multiple. Step 1, we write the prime factorization of each number. And step 2, the LCM is the product of each prime, the greatest number of times it appears on a single line. Now it'll make more sense once we look at an example. Yeah, clear that off. If I'm trying to find the LCM of 20 and 24, let's say. Step 1, write the prime factorization of each number. 20 would be 2 times 2 times 5, and 24 would be 2 times, well, 3 2s, 2, 4, 8 times 3. So then our LCM is a product of each prime the greatest number of times it appears on a single line. They have to have just primes over here, or 2, 3, 5, 7, 11. So we'll start with 2. I got 2 2s here, and I got 3 2s here. I'm looking for the greatest number of 2s on a single line. Well, my greatest number of 2s on a single line is right here, 3 of them. Now notice we're not counting how many 2s there are. We're looking for the greatest number on a single line. Then I go to my next prime, which is 3, and I'm looking for the greatest number of 3s on a single line. There's 1 here, none here, so the greatest number of 3s would be 1. And then I go to my last prime, which is 5, and I'm looking for the greatest number of 5s on a single line. There's 1 here and none here, so the greatest number of 5s would be 1. So 2, 4, 8. We have 8 times 3 is 24 times 5. And assuming I'm doing my basic math right, that would give us 120. And that would be our LCM of 20 and 24, least common multiple. Well, least common multiple is actually used in other techniques. We'll see that not only in adding and subtracting fractions, but we also see it in linear inequalities, linear equations, which is in Chapter 2. If I'm going to take a look, let me put a note here. Finding the LCD, least common denominator, is the same technique as the LCM. And we're going to find the least common denominator when working with fractions. So adding and subtracting fractions. Step 1, we want to get a common denominator. And that's the LCD. Step 2, you add or subtract the numerators, the top parts, and put into a single fraction. And then step 3 is you simplify the fraction. Okay, so let's take a look at adding two fractions. Say we got, say 3 over 10 plus 1 over 12. Now the same principle holds true for subtraction, so I'll just show one addition. Step 1, we want to get a common denominator. So we want to find the LCD of 10 and 12. And remember I said it's the same steps as the LCM. So it's these steps right up here. So our first step is to write the prime factorization of each number. 10 is 2 times 5. 12 is 2 times 2 times 3. Then our LCD, I'll start with my first prime, which is 2, and I'm looking for the greatest number of 2's on a single line. There's 1 here, there's 2 here, so the greatest number of 2's is 2. Then I go to the 3. I'm looking for the greatest number of 3's on a single line. There's none here, there's 1 here, so we'd have 1. And then I'm looking for the greatest number of 5's on a single line. There's 1 here, none here, so it'd be a 1. So 2 times 2 is 4, times 3 is 12, 60. So this would be our least common denominator. So over here for step 1, we want to get a common denominator. Now you look at your old denominator and you ask, what does that multiply by to get the new denominator? Well, we multiplied to 10 by 6, so we have to multiply the top part by 6. Mathematical principle behind that is whatever you multiply by the denominator, you have to multiply by the numerator. On our second fraction, we multiplied the old denominator by 5 to get 60, so we have to multiply the top part by 5. So that gives us 18 over 60 plus 5 over 60. Now step 2, add or subtract the numerators and put into a single fraction. In this case we have a plus here, 18 plus 5, and we put it into a single fraction. And that gives us 23 over 60. Now normally we'd try to simplify this fraction, but that doesn't look like it'll simplify at all. 23 I believe is prime, so that would be our answer. Fractions is kind of a longer process on that. Now the next topic is evaluating algebraic expressions. So let's take a look at that. And I'll send this Word document out. You probably want to do some formatting before you print it, since I'm putting each one like on a separate page. So evaluating algebraic expressions. Our first step is to replace all variables with sets of parentheses. Our step 2 is to substitute, plug the appropriate values into the parentheses. And step 3 is to simplify. Now simplify in math means a lot of different things. In this case, you can think of order of operations. Now an algebraic expression is nothing fancier than an expression that has variables in it in some sort. For example, if I had a squared b minus c to the third, and our instructions, we want to evaluate it. So we're going to evaluate a squared b minus c to the third when a is equal to -1, b is equal to 2, and c is equal to 3. This would be, for example, if you had a formula. If you're going to engineering or something of that type and you're given a formula and you need to plug in your numbers and then find out what the value is. This is exact same principle. Now step 1. No matter wherever we're evaluating, it's always a good idea to replace all your variables with sets of parentheses. So I'm going to have parentheses squared times parentheses minus parentheses to the third. Now everything else remains exactly the same. All I did is replace the letters with sets of parentheses. And then step 2. Substitute the appropriate values into the parentheses. Well, over here, remember we said a was equal to -1. So where the a was, I'll put in a -1. We said b was 2, so where the b was, we'll put in a 2. And we said c is 3, so wherever I had a c, I'll put in a 3. And actually, I probably should have put that right there. Those are usually done in the same line, those two steps. Now step 3. Simplify. Use the order of operations. Please do what's inside the parentheses. There's nothing to do inside the parentheses. Excuse exponents. Well, my first exponent from left to right is right here. So we got negative 1 squared. And negative 1 squared means negative 1 times negative 1, which gives us a positive 1. And everything else carries down. Well, I'm still doing the exponent part, the excuse part. Here's another exponent. Everything else carries down. Now 3 to the third is 3 times 3 times 3, 3 threes, which is 27. So replace that. Please excuse my dear. Multiplication division. Well, there's only one multiplication division right there. So 1 times 2 is 2, minus 27. And then Aunt Sally, addition and subtraction. Well, this goes back to our note on our signs. When combining numbers, this is where they're different signs. One's positive, one's negative. You ignore the signs, so I got 2 and 27. Subtract a smaller from larger. 27 minus 2 is 25. The sign of the answer is the sign of the larger number. Larger number is 27, which originally was negative. So our answer will be negative 25. And that's how you would evaluate an algebraic expression. Now the next topic is solving linear equations. Now solving linear equations, we have our note that's at the top. It says at any step, combine like terms and combine numbers. And we have our first step that says to get rid of parentheses. And you do this via the distributive property. Step 2 is to get rid of fractions. And we multiply everything. And I'll talk more about what everything means once we work some problems. Multiply everything by the LCM of all the denominators. Step 3, get all the terms with x on one side, numbers, constant term, on the other side. Step 4, divide both sides by the number in front of the x. That's coefficient. Now I like a step-by-step approach that works 100% of the time. So you never see me in any of my videos ever use shortcuts. If you know when to use shortcuts, fantastic. That's where a lot of students get lost. And I like one method. If I can find one method that works 100% of the time or as close as I can get to it, that's what I'll always go with. So let me make up an example. I got negative 3 times x minus 1 equals 5x minus 7. Step 1, get rid of parentheses. Well, I say via the distributive property. Notice we have a number right in front of the parentheses here. When you have a number right next to the parentheses, that indicates multiplication. So we're going to take the negative 3 and we'll multiply it times each term inside. Now I haven't really covered what a term is because due to the time, but terms are separated by pluses and minuses. So x would be a term and this negative 1 would be a term. So I'm going to take negative 3 times x. Now I'll take negative 3 times negative 1. And you just follow lines to see what to multiply together. Negative 3 times x is negative 3x. Negative 3 times negative 1 is a positive 3. Equals 5x minus 7. Step 2, get rid of fractions. Don't have any fractions. Step 3, Get all the terms with x on one side, numbers on the other side. I'm writing this in terms of the x, but you can have any variable when you're solving equations. Well, I'm going to take this 5x and move it over to the left side, and I'll take this 3 and move it over to the right side. When you move anything across or equals, your sign changes. So the positive x becomes the positive 5x becomes a negative 5x. The positive 3 becomes a negative 3. Now at any step, combine together like terms. Let's talk about what a like term is. Like terms is where you have the same variables to the same powers. Now these are both x to the first power, so these would be considered like terms. Now combining like terms, you add or subtract the numbers in front, and the variable part remains the same. So you add or subtract the numbers in front, and the variable part remains the same. What I mean by that is here we have a negative 3 and negative 5, which gives us a negative 8, and then the variable part remains the same. Now up here, we said also combine numbers. Negative 7, negative 3 is negative 10. Step 4. Divide both sides by number in front of the x. Number in front of x is a negative 8, so I'll divide both sides by negative 8. And those negative 8s will cancel. And over here, remember, a negative divided by negative is positive, and 10/8 reduces to 5/4. And that would be our answer. Let's grab a drink here. Now you may have learned that a little bit differently. You may have learned where you have negative 3x plus 3 equals 5x minus 7. You may have learned putting a negative 5x underneath like that. And that gives you negative 8x plus 3 equals negative 7, and then proceeding from there. That'll give you the same answer, but sometimes in college algebra, you need to move so many things back and forth across your equals that it really is just as easy as to move it to the other side and change the sign that's in front of it. Let's look at one with fractions. We've got 1/2 x minus 1/3 equals 5x minus 7. Step 1, we want to get rid of parentheses. We don't have any parentheses. Step 2, get rid of fractions. Multiply everything by the LCM of all the denominators. Well, this one's a pretty straightforward one. LCM of 2 and 3. Remember, to find the LCM, we would first write prime factorization of each number. Well, these are both prime. So then our LCM, we start with each prime, and I'll start with the 2. And we'll look for the greatest number of times it appears on a single line. When I say on a single line, I'm talking to the right of the equals. There's 1, 2 here, there's no 2's here, so greatest number of 2's is 1. Then I go to the 3. We're looking for the greatest number of 3's on a single line. There's none here, there's 1 here, so the greatest number of 3's would be 1. And our LCM would be 2 times 3, or 6. Now that says we're going to multiply everything by the LCM of all the denominators. When I say everything, I'm talking about what's separated by pluses, minuses, and equals. So it takes 6 times 1/2 x minus 6 times 1/3 equals 6 times 5x minus 6 times 7. Now when we do that, 6 and 2 are both divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. 3 and 6 are both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So I'm left with 3 times 1, 3x, minus 2 times 1, 2, equals 6 times 5 gives us 30x, minus 6 times 7, which is 42. Step 3, get all the terms, the x on one side, numbers on the other side. So I'm going to take this 30x and move it over to the left side, and I'll take this negative 2 and move it over to the right side. You move anything across or equals, your sign changes. So the positive 30x becomes a negative 30x. The negative 2 becomes a positive 2. Our note up at top said any step combined together like terms. 3x minus 30x is negative 27x. And combine numbers. Negative 42 and 2 gives us negative 40. Step 4. Divide both sides by number in front of the x. Number in front of x is a negative 27, so I'll divide both sides by negative 27. And when I do that, these negative 27s cancel. And over here, a negative divided by negative, the negatives cancel. Because a negative divided by negative is positive. And I'm left with 40 over 27. That doesn't look like it'll simplify any. Oftentimes I come up with nasty fractions like this when I make up a problem. It doesn't come up nice like x equals 1 or x equals 2. Now that's solving linear equations. Now I'm going to skip over set operations in interval notation. I'll come back to it. But let's take a look at solving linear inequalities. And we'll take a look at what a linear inequality looks like also. So solving linear inequalities. We have our note up at top. Says at any step, combine like terms and combine numbers. Our first step says to get rid of parentheses. And we do this via the distributive property. Our second step says to get rid of fractions. And we'll multiply by the LCM of all the denominators. Step 3 is we'll get all the terms with x on the left side, numbers, constant terms, on the right side. Step 4, we'll divide both sides by the number in front of the x, coefficient. And we have a note. It says if you multiply or divide both sides by a negative number, flip the inequality symbol. And I'll show an example of that. Shouldn't have had the phone in here. Sorry about that. And just clearing off my tablet. Okay. Now we got 3 times x minus 2 is greater than or equal to x minus 7. Okay, first step, get rid of parentheses. Well, we're going to take the 3 and multiply times the x and times the negative 2. Same principle as when we're working linear equations. So 3 times x and 3 times negative 2. Well, 3 times x is 3x. 3 times negative 2 is negative 6. Step 2, get rid of fractions. Don't have any. Step 3, get all the terms of the x on the left side, numbers on the right side. So I'm going to take this x and move it to the left side. I'll take this -6 and move it to the right side. When you move anything across your inequality, just like when you're working with equations, it changes the sign of it. So this positive x becomes a negative x, and this -6 becomes a positive 6. Just like before, at any step we combine together like terms, combine together numbers. 3x minus x is 2x. -7 plus 6 gives us a -1. Step 4. Divide both sides by a number in front of the x. Number in front of our x is a 2, so we're going to divide both sides by 2. Now, a lot of people start, whenever they see a negative, they'll start flipping the inequality symbol. But it's very specific. It says if you multiply or divide both sides by a negative number. We're dividing both sides by a positive 2. So this inequality symbol does not change. It stays greater than or equal to. Now those 2's cancel, and I got x is greater than or equal to -1/2. Now this is basically our answer. I skipped over set operations and interval notation. Part of what's included in here is how to write this in different forms, which we'll talk about. There's one called set builder notation, and these really do apply when you're working with inequalities. Set builder notation, you put curly brackets, you put x with a vertical bar, and then whatever your answer was. Now how you read that, this says, these curly brackets means a set of. So this says a set of all x values such that this is true. So that's how you read interval notation. Now whenever you have a greater than, it always goes to positive infinity. So this would be -1/2, comma, positive infinity. Now positive infinity is a very large number you can never reach. What's the largest number you can think of? 1 billion? No. 1 billion plus 1. 1 billion plus 2. You can keep adding over and over, so you can never reach it. To indicate that you can never reach it, we put a parentheses on there that means it does not include that value. Now this is specifically an x is greater than or equal to. Notice the line underneath. Whenever you have the line underneath, that always means you put a bracket. And this notation is called interval notation. So again, line underneath your inequality symbol means bracket. And there's a graph also. The graph is very easy if you got interval notation. Bracket on -1/2, bracket on -1/2. And you shade whichever way it's opening. It's open to the right, so I shade to the right. And that would be our graph. Now let me show another example of that. Let's say I got 1/5 x minus 2 is greater than 3x plus 1. And our steps. First step says get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply by the LCM of all your denominators. Well, we only have one denominator, the 5. When you only have one denominator, that automatically is your LCM. So we're going to multiply the 1/5 x by 5 minus, we'll take 5 times 2, greater than 5 times 3x, and 5 times 1. What do we multiply by? We multiply by whatever is separated by pluses, minuses, and inequality symbols. So that's why we multiplied it by this entire fraction here. Here's a minus, that's why we multiplied by the 2. Here's a greater than, that's why we multiplied by the 3x, and here's a plus, that's why we multiplied by the 1. Now here these 5's cancel, and I got 1x or x minus 5 times 2 is 10, is greater than 5 times 3 is 15x plus 5 times 1 is 5. Step 3. Get all the terms of the x on the left side, numbers on the right side. So I'm going to take this 15x and move it over to the left side. Now I'll take this negative 10 and move it to the right side. Anytime you move anything across your inequality symbol, the sign changes. So the positive 15x becomes a negative 15x. The negative 10 becomes a positive 10. At any step, combining like terms. Now there's no number in front of this x, but remember there's always an invisible 1 there. So that really says 1x minus 15x, which would give us negative 14x. 5 plus 10 is 15. And don't be overwhelmed by this. If you really haven't mastered combining positives and negatives, this may be a little bit confusing at this point. Once you go through and you work the problems out of the ebook involving that, it'll make more sense. Step 4. Divide both sides by number in front of the x. Well, number in front of x is a negative 14, so we'll divide both sides by negative 14. Now, if you multiply or divide both sides by a negative number, we're dividing both sides by a negative 14, which means we flip our inequality symbol. So the greater than becomes a less than. Now these negative 14s cancel here. And I got x is less than negative 15 over 14. And this is our answer, but we're going to look at all our different forms. We had our set builder notation, which you have curly brackets, you have x with a vertical bar, and then whatever your answer was. We have our interval notation. Since it's a less than, that means it's going to negative infinity. And you always put your smaller number first. So that's negative infinity and negative 15/4. Just like when we were talking about positive infinity, you never reach infinity, so that'll be a parentheses. Now to decide whether this should be a parentheses or brackets, this is specifically a less than. There's no line underneath. Remember, a line underneath is when you put a bracket. So that'll be a parentheses there. Now for our graph. If you have interval notation, the graph is very easy. Parentheses on negative 15/4, parentheses on negative 15/4. And you shade whichever way it's opening. It's opening left, so I shade the left. And those would be our 3 forms. And that's solving linear inequalities. Now, our next topic is solving compound inequalities. So let me clear this off. Unfortunately, my tablet is a fairly cheap one, so it works real well, but the software program doesn't. If I try to do a new page, it does it for 2 or 3 times and crashes, so it's just easier to undo everything. Okay, now compound inequality. Let me talk about what that would look like. This would be something like this. 3x minus 1 is less than 5, or 4x plus 2 is greater than 6. So that's an example. Or you could have negative 5 is less than 4x plus 2 is less than 7. That's also a compound inequality. Now, to understand the compound, how to solve a compound inequality, you have to know whether you're dealing with this type or this type. Now, this type, you could have an or here, or there could be an and between them. So we're going to take a look at solving a 3-sided compound inequality first. Now, our first step. Now, I'm not going to put down any more the note where you combine together like terms, combine together numbers. That's actually true throughout algebra. But our first step, is to get rid of parentheses. And we do this via the distributive property. Now step 2, get rid of fractions. You multiply everything by the LCM of all the denominators. Step 3, get all the terms with x in the middle, numbers on the other two sides. Step 4, divide all three sides by the number in front of the x. And again, that's your coefficient. And we have a note that says if you multiply or divide all three sides by a negative number, you flip the inequality symbol. So these are steps we're going to go through to solve a three-sided compound inequality. And we'll come back to that top example. So let's take a look at this one here. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Step 3, get all the terms with x in the middle, numbers on the other two sides. So this 2, instead of just taking it over the other side, I'm going to take it over both the other sides. It's the same principle as subtracting 2 from all three sides. So that gives us -5 minus 2 is less than 4x is less than 7 minus 2. Now -5 negative 2 is -7 is less than 4x is less than 7 minus 2 is 5. And then step 4, divide all three sides by a number in front of the x. Well, number in front of x is a 4, so we're going to divide all three sides by 4. So we've got -7 divided by 4 is less than 4 divided by 4x is less than 5 divided by 4. So that gives us -7/4 is less than x is less than 5/4. Now this is our answer, but we're going to look at the different ways to write that. Set builder is always the easy one if you got your answer. You just put curly brackets, put an x with a vertical bar, and then whatever your answer is. That's our set builder notation. Now our interval notation. When it's between two numbers like this, going from a smaller number to a larger number, you simply put your smaller number, comma, your larger number. There is no infinities involved. Now neither one of these has lines underneath the inequality symbol, so both of these will be parentheses. And then our graph, again, very straightforward if you have interval notation. Parentheses on -7/4, parentheses on -7/4, parentheses on the 5/4, parentheses on the 5/4, and you shade whichever way they're opening. They're both opening inwards, so I shade inside. And that would be our graph. And that's how you solve a three-sided compound inequality. Now solving a compound inequality separated by and or. That's this top example here. We've got a compound inequality and it's separated by either an and or. Our first step is to solve each inequality separately. Then step 2, graph the solution on the same number line. Usually best if you can use different colors to do that. Now if you got an or, then what the or means is your answer is where anything is shaded. Now if you have an and, your answer is where they are both shaded. And we'll take a look at both examples of that so we see what in the world I'm referring to there. So let me clear this off. And again, I know we're like in Chapter 2 material here. Don't get overwhelmed by this. Math builds. So as you go through and do the first chapter, then you know, all these different pieces will kind of flow together. Okay. Step 1. Solve each inequality separately. So in this one, this is just a linear inequality, so we used our same steps we did before. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with an x on the left side, numbers on the right side. So I'll take that -1 over. You take anything across your inequality symbol, the sign changes, so -1 becomes a +1. Combine numbers in a step. 5 plus 1 is 6. And then our last step of solving linear inequalities, divide both sides by number in front of your x. So divide both sides by 3. Those 3's would cancel. And 6 divided by 3 is 2. Now we want to do the same thing on this one. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with an x on the left side, numbers on the right side. So I'll take the 2 over. It becomes a -2. Combine together numbers. 6 minus 2 is 4. Last step. Divide both sides by number in front of your x, which is a 4. So those 4's cancel. And we end up with x is greater than 1. And I didn't mean to make up an oddball case here, but this one came out as an oddball case. We'll see why. A lot of times you don't understand the answer you get until you look at the graph. Step 2, graph the solution on the same number line. Graph the solutions on this same number line. Now x is greater than 1. Well, here's 1 and here's 2. X is greater than 1 would, it's a parentheses because there's no line underneath. And greater than is going to positive infinity. So it looks like that right there. Now x is less than 2. It'd be a parentheses because there's no line underneath. And less than's going to negative infinity. So I'll shade this way. Now for an OR, we said for an OR, our answer is where anything is shaded. Well, if you look at this, it's shaded everywhere. So our answer would be negative infinity to positive infinity. Now this actually would be a perfect one for the AND. So let me work this again with an AND in there. So we've got 3x minus 1 is less than 5, and 4x plus 2 is greater than 6. Now it's going to give us the same answer. We'll have x is less than 2, and we'll have x is greater than 1. Difference will be there'll be an AND in here. So if we look at our graph then, for the AND, our answer is where they are both shaded. Well, they're both shaded between 1 and 2. And then parentheses on the 1, parentheses on the 1. Parentheses on 2, parentheses on 2. And that would be our answer for the AND. And this is our answer for the OR. Now let me show you one example where we look at the graph and then we're going to write down what the answer is, because there's something additional I need to show you. If I graphed a problem, and let's say that's 2, and it's going this way, and let's say this over here is 5, and it's going in this direction. And this is an OR problem. The OR says the answer is where anything is shaded. So this would be our answer. It's going to the left, so it's going to negative infinity. Infinities always have parentheses. Parentheses on 2, parentheses on 2. This one is going off to positive infinity, so this will be 5, comma, positive infinity. Infinities always have parentheses. Bracket on the 5, bracket on the 5. Now, if you got two different parts to your answer, how you connect them is with this symbol right here. This symbol is the union symbol. Now, part of what we're looking at with working with sets, over here, I said I was going to skip the set operations and interval notation, because that's kind of covered with what we're doing with linear inequalities and compound inequalities. Now let's take a look at absolute value equations. Is everybody good? Is there any questions, anything?
I think you've already gone past my question, but you go right ahead. I'm following along with you.
Okay. Well, I plan to do this one. I don't think I'll have time to do this second page, but I will work these out in a YouTube video and send them out to you. It'd probably be kind of overwhelming at this point anyway, because I want to leave time at the end for questions. So let's take a look at absolute value equations. So our absolute value equations says if you have the absolute value of something is equal to something else, then we drop the absolute value bars, we set it equal to positive the other side, and we drop the absolute value bars and we set it equal to negative the other side. Now this is really as vague as what I just said. If you have the absolute value of something is equal to something else. It can be anything in here. And it can be, in theory, anything over here. Now there is an oddball case that goes along with this, but I won't cover that with what we're looking at tonight. Now the absolute value has to be by itself on the left side. So let's take a look at this problem right here. Now notice that the absolute value is by itself on the left side. Nothing in front of it, nothing after it. We just have the absolute value of something. From our formula, whatever's inside our absolute value is our P, and whatever's on the other side is our Q. And our formula says P is equal to Q, and P is equal to negative Q. And that's just from right here. So now everywhere I have a P in my formula, I'll plug in 2x minus 1, and everywhere I have a Q, I'll plug in 5. So I got 2x minus 1 is equal to 5, and I got 2x minus 1 is equal to negative 5. Now at this point, after you've applied that formula, these are both linear equations. So I'm going through my steps for solving a linear equation. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with an x on one side, numbers on the other side, so I'll take that negative 1 over. And that becomes a positive 1. Remember, when you take anything across your equals, your sign changes. 5 plus 1 gives us 6. Then our last step in solving a linear equation is to divide both sides by the number in front of your x. So we'll divide both sides by 2. And 6 divided by 2 gives us x equals 3. Those 2's cancel. Now we want to do the same thing on this one. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with x on one side, numbers on the other. So I'll take negative 1, move it over. You take anything across your equals, your sign changes, so negative 1 becomes a positive 1. Combine numbers in a step. Negative 5 plus 1 is negative 4. And last step, divide both sides by number in front of your x, so we'll divide both sides by 2. When I do that, these 2's cancel. And negative 4 divided by 2 gives us negative 2. And those would be our two answers. Now, if I had a different, I'm not going to work the entire problem, but if I had a problem that looked like this, well, the absolute value is not by itself on the left side. And specifically, there's a -3 in front of the absolute value. What that indicates multiplication. Just the same as when we had a number next to the parentheses, if you have a number next to the absolute value, that's multiplication. So to get the absolute value by itself, we always do the opposite operation. So here, I would divide both sides by -3. Now when I do that, those -3's cancel. And we got the absolute value of x plus 2 is equal to negative divided by negative is positive, and 6 divided by 3 is 2. Actually, I guess I could finish this. Now we got the absolute value of something is equal to something else, and that's all the formula says. So whatever's inside our absolute value is our p, and whatever's on the other side is our q. And our formula says p is equal to q, and p is equal to -q. So everywhere I have a p in my formula, I'll plug in x plus 2, and everywhere I have a q, I'll plug in 2. So I got x plus 2 is equal to 2, and x plus 2 is equal to -2. These are linear equations. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with x on the left side, numbers on the right side. So I'll take that 2 over, and it becomes a -2. Remember, you take anything across your equals, your sign changes. 2 minus 2 is 0. That'd be our first answer. And here, I'll take the 2 and move it over. Take anything across your equals, your sign changes, so it becomes a -2. And -2 and -2 gives us -4. And those would be our two answers. Now I want to talk briefly about how to be successful in mathematics. Whether you're in the classroom or whether you're online, this kind of still holds true. Part of it is to have a schedule. That's kind of important piece. For example, in this first unit, which is corresponds to the first week, you see we have a total of 7 items. In the perfect world, and I know that's not always true because I work full-time too, so I understand that. But in a perfect world, how you plan this is you do one of these each day of the week. Now the discussion is actually due by Thursday, so you need to post your initial discussion on that. But you don't have to have a real firm understanding of that section, where you can work every problem in there, but you need to read through it. So, I might read or do the assignment 1.1 and assignment 1.6 on Monday, Tuesday, Wednesday do the 1.2, and then kind of plan it from there. If you save these all for Sunday, say, well, I'll get up early and put in a good day, you're going to be overwhelmed, very overwhelmed. But if you tackle it with a schedule, whatever's appropriate to your times that you're available, and I can't set that for you, you have to look at that yourself, then it'll be a very reasonable pace, and you won't be stressed and so forth. Second, do problems. That's the only way you can get good at math. I have students come into my regular class, and they just sometimes they'll write down what I'm writing on the board. Sometimes they don't. And then I have some of those students do not do any homework at all. And you can't get good at something unless you practice, whatever that might be. If you're learning to play a guitar, you practice. I bought a guitar when I was dating a girl in a band, and I practiced for about 15 minutes. My fingers got real sore, and I gave up. It was probably about the biggest waste of money I did on a guitar. She told me I needed to play until I got calluses. Again, that's true with anything. If you don't practice, you'll never get good at it, unless you already know it. Now, where the practice problems are in this is if you click on Lessons, you'll see some practice problems in here. It says complete the suggested problem sets below. These will not be graded, but if you can successfully complete at least 5 problems in each section, you should do well on the quiz. Only attempt odd-numbered problems, and then check your answers in the back of the textbook. This is a generalization. Some people may be able to get by with 5 problems in each section. Maybe in some of them you'll have to do 10. You'll know as you're working the problems. If you don't have that comfort level down, then do more problems. Ask for help. If you're struggling on some of those problems, those are not for a grade, and I'll help in whatever way I can on that. For the discussion board, you'll find a class question board here, and just come in here and post what page and what problem that you're having trouble with, and I'll work it in the YouTube format, and I'll post a YouTube video. And I won't skip any steps. I'll explain exactly what I'm doing in each step, and that way if I put it out there, it'll benefit everybody. And if you see somebody else's out there that you know the solution to, go ahead and help them. I didn't really understand mathematics until I started teaching it. When I started explaining it, my level of expertise increased many times when I did that. And you know, if you need to get, and I should say ask for help, you know, and you know, an instructor might be so egotistical to think that they're the only one that can provide the help. A lot of times you have friends that help you, tutors. My wife, when she went through the algebra, she of course had me, and she asked me for a lot of help and so forth. So I realize there's many different areas where you can get that help. Is there now I want to leave this last part of the session for any questions you might have. And assuming I can bring up the participants. There. What questions were there on anything?
I don't think I have any questions. I think it's going to be key for me to do what you said, just to do it and do it and do it and do some practice.
Right.
If you're going to send that out to us, I'll have that as a guideline. So.
Yeah, and I'll always create these, and like I say, you're not bothering me if you ask me to each week. If there's 15 problems you need to see worked on YouTube video, I like creating this stuff. I like getting online and do this. So you're not asking me to do anything I don't already enjoy. What other questions are there?
I had a quick one.
Okay.
This is Rory, sorry. So on the solving linear inequalities, you had the example, it was 3 and then parentheses x minus 2 is greater than or equal to x minus 7.
So 3, what was it again?
It was 3 and then parentheses x minus 2 in parentheses, and then is greater than or equal to x minus 7.
Okay.
So the main part I understood most of it, but the when you broke down the parentheses section, you had it broken down to 3 times x, and then you had plus 3 times negative 2. And that's where I kind of got confused on that part, because when you're multiplying 3 by each of the variables inside the parentheses, it looked to me like it would have been 3 times x minus 3 times 2.
And that's fine.
When you write it out. I mean, the answer is the same, I guess, because it's either plus 3 minus 2 or times the negative. But is that when you're doing it consistently, is it okay to do that? I mean, is it?
Right. Either way is fine. You have to develop a method such you don't lose track of the negatives. Some
Right.
people like to put it out in front like this, and some people like to put it inside the parentheses so they'll specifically not lose track of it. So yeah, either method's fine.
Okay, I just want to clear that up because I know in the next example you did it opposite, but I know the answers came out the same, but in my finite mind it was confusing me.
You know, the most popular method is for people to leave the negative out in front, and this is the way I taught it for years and years, where I always put the negative inside because I thought that way students wouldn't lose it as easy. But then I finally came to the realization that students liked having it out in front. So I'm trying to, obviously I'm not consistent all the way across the board. I'm trying to always put it out in front now.
Okay, no, it makes sense. Thank you.
Mm-hmm. What other questions?
Yeah, I think I'm good until I get there.
Okay.
So this will be a good guide to fall back on.
Okay, well, I'm going to save this, and I'll upload it to YouTube tonight, and I will post it in the, let me show you where. Over here where it says collaborate sessions, this is where I'll post it at. Probably put it, maybe I might put it right underneath where the actual meeting was. And it'll be in YouTube format. You can fast forward, you can rewind, listen it over and over, and so forth. Well, if there's no other questions, then we're done for the night. And I will be on every Monday night doing the same type of deal for direct instruction. I will also be on Sundays at 4 o'clock, and I get on just to answer any individual questions that people have. In this I open up for other classes too, but what I'll do is if there's multiple people, I just bounce back and forth between the questions between them. I open it up to other classes because usually nobody signs on. So it gives me somebody, you know, I'll have somebody on I can answer questions on. I'll stay on there for about 15 minutes, and if nobody signs on, then I log off. But if you know you're going to be late, just let me know. Say, hey, I'm going to be on there at 5:30, and I'll sign back on and answer whatever questions you have.
Okay, David, thanks for your time. Appreciate it.
Yeah. Have a good night.
You too.
Yeah, you too. Thanks.
Thanks a lot, David.
Yeah. Have a good night. You're welcome, everybody.
Yeah.